All right. Well, good morning. Just getting started here. Get some tunes going. All right. Double check our their social media things. Oh. Just currently doing some quick posts for the live stream here. Stealing from before. Why does it keep selecting more than it intended? I'll start at the top. Cool. Then we got it that time. We'll do one more. Can't remember the URL. B-Sky, that's what it is. I'll take the one we just did on X. Throw over there. You never know. All right, cool. That's out of the way. Double check everything's working. Looks like we're good. Shove that over here out of the way. we'll go ahead and get started. All right, so if you were with us last week, we had started on this fun little project to take some blog posts that we gathered from the Justice Department, and we put it through an embedding process using the LLM, and now we have categorized it and has extracted keywords from the blog post. However, I did notice as part of this work that one of the problems that we ran into is that inside the text that it extracted, make sure I'm not muted. I've done that before. I did like a whole recording where the entire thing was muted. Don't feel very, it's very stupid when you do that. So I actually took the liberty and went ahead and ran through some of the code previously. Let's see here, the create clusters. Now, I think we need to just kind of adjust some of these a little bit, maybe. Because as it stands, I got two problems. Problem number one is that we did not properly filter our content very well. And such that, here, I'll show you what I'm talking about. We look at our cluster labels and whatnot. That one's a little harder to see. The keywords, yeah. We have MBSP a lot. And if you're familiar with HTML, that's a non-breaking space. So, we should probably filter that out. Because I think that's throwing our data off a little bit. Maybe a little bit. I don't know. Maybe it's not. The problem is it takes almost 20 minutes to do the embedding. So do we redo the embedding? I don't know. I don't think it changes what we're doing next if we don't redo the embedding. Maybe it's not worth the effort. So, I don't know. This coffee is too weak. I messed up when I made it. I don't know what happened, but I messed up. Mistakes were made. I don't know what happened. All right. I have to just keep it the way it is for now. I'm not happy with the keywords they extracted because these right here annoy me. Oh man, what to do? I really want to redo the embeddings, but the problem is that it takes 20 minutes on my machine because it's super slow. We could go ahead and fix that and see if it changes anything. And then we could always we can take what we have so far and go ahead and use that to continue with our search. With our search. I think that might be for the best. I'm gonna have to find some better music though. We have to find some better music. This is, I like it, but at the same time, it is just not. We gotta find something a little bit more upbeat. What's this? Oh, practicing. Yes. Poops. I'm not doing this right now. All right, we'll just keep it where it's at. All right. Let's go ahead and fix the MBSP issue. Let's put that out of there. Let's take a look at the data that we have. There's page 1. And let's see here. Well, it's easier to open it in the browser. I don't know why I opened it up in there. Because inside the browser, we can actually take a look at it and see what is the deal and kind of go from there. All right, what we got? So one thing we could strip out are these \n's. Those denote new lines in the data. What else we got? Is that all we got? We just got some. No. Got some. All right, so we got some /n/t's, and we got some MBSPs. We're gonna strip all that out. I feel like it's just interfering with embeddings a little bit. Making things relate that probably wouldn't otherwise relate, maybe. I could be wrong. Maybe it's not affecting it at all. But it just irks me that it's in there. Like it shouldn't be there. And it's totally there. So I think we're gonna go ahead and just take it out and go from there. Let's go ahead and store what we currently have with our clusters You know, we'll just copy this whole. Oh, what do I want to do? I want to store all we have right now. So we're going to copy clusters, and we're going to copy doc embeddings, doc index, and doc metadata. Yes, and copy all of those into our artifacts trial 1. Okay. All right, that way I won't feel so bad when and if we mess this up. All right, cool. So, like I said, I want to go back into our embeddings, and I want to, on our data, as we're passing it over, we want to do some filtering on that data. So here we are, we're doing the encoding here. I know we did something up here where we're doing some filtering somewhere. Here, prep text, simple, cleaner to avoid super long text. So we can actually do it here. All right, so I use Python sometimes, but not a lot. So let's filter characters Python. That's for one. And the other thing we're going to do, we're going to go down here and we're going to we can comment all this out right here. I'm going to do something extra for you. And that is, I am going to do better with my Vim motions. I've been using Vim for the better part of 15 years. And I still don't have I've learned nuances. You ever seen somebody who types and hunt and packs? Yeah, kind of like that. Except for I don't hunt and pack. I have some basic motions that I use, and I know it does a whole bunch of other stuff, but then I keep forgetting to use them. So I do a lot of this where I just hold down J or K and use $ to get to the end and 0 to get back to the front, but I rarely use like 4W, you know, it's just really weird. All right, let's see here. Okay, so all right, so filtering out some characters. So we actually want to filter out quite a few. Yep, we want to do this. So let's go ahead and pull up our regex 101, just because I think that's probably our easiest bet right now. And we're gonna go grab some of that sample data that we want to clean, because that's what we do. And I think this is a good one. And we're gonna go chunk it over here. All right, so some of the characters we're wanting to grab are \n. That's one. We want to capture that anywhere. There we go. So we got backslash in or R or T. T. Oh. Oh, crap. Definitely that one. That's what I thought. Can't seem to capture. Does that captures? It's not capturing the group though. It's capturing slash followed by n. I guess that's okay. Is that all we see? That all we see? I think that's it. I think that's all we want to pull out of here, right? Like, let's, I don't know, let's go take a look at a couple of others just to see. What we got here? What we got? That looks fairly clean. Oh, no, there's our N, there's our T's. Let's make sure it works for this one. I'm pretty sure it will. Yep. I don't see any other gotchas that we want to get out of here. Oh, here's a good one because they're all spaced together and put in and kind of shoved. But I think we're okay. I think this is good. All right, cool. Let's go with that. So let's right. Can I do that? No, that's really gonna mess this up. I don't feel like I have to group it though. All right, let's see what happens. I think I can just take this out. Yeah. Because I don't need to actually do the capture. All right, so let's go ahead and those of us just joining us, we're actually taking and filtering out some of this data that is inside of the raw data that I think might be affecting our encodings. Make sure this is right. So GM. GM by default. All right, let's do it. Let's see what we got. I don't want to print out. Do that. No, let's just do it. Let's do it anyways, and then we can just take a look and see. We'll do, I don't know, we'll do what? 5? Take a look. Let's open up a new thing. Well, that's taking a little bit longer than I was hoping for. I think it's any time that you include and you load up that LLM. It just takes a minute. I believe is the problem. Okay, here we go. We stop. We still have our MBSP. Come on, come on. What did I do wrong? Is it because I didn't assign it? Is that the problem? Right, because I'm an idiot. Okay. Try number 2. Hurry up and wait. That's where we're at. Hurry up and wait. Still not right. Why are you not taking it? Maybe I don't have to. Maybe I don't have to escape it. Hey. I think that worked. Cool. Because I don't see any of the naughty characters. Nice. All right, cool. Ella note. Thanks, Copilot. That was so easy. Okay, so now that we have that, we can go ahead and let it I really don't want to do this, but I really feel like it needs to happen. This is going to take a minute. So I am actually going to leave this going. And then kind of go and look at the categorization on the other side, because I don't fully understand all of that as written. So I want to try to understand that better, and how, maybe massage it a little bit to see how close we get to it. How long is it? I'm waiting for it to give me a progress, see how long it's going to take. I want to say it's probably going to be at least 20 minutes. Because we're using our local LLM. We're using that 17 minutes. Oh, that's not too bad. We're using the Snowflake Arctic Embed V2 CPU version, which is this guy here. Which is, just a modified version of this with the X-formers. Because if you try to run the default one, it is going to complain at you because you're not cool enough to have a GPU. I mean, that's sort of and so my laptop is a CPU. Anyways. We might eventually change this out for something else just to see if we get to see anything different. But for now, this is what we're using, and we're using it local. So it just takes a minute. I mean, it's just no getting around it. Okay, the next part I wanted to do is I'm going back in here and we're going to double check how we're creating our like I said, I'm going to leave that open, let it go. Our machine is not happy with us right now at all. It is very mad. Matter of fact, let's take a look. What's it doing? OBS, of course, is killing it, and then Python 3 is killing it. because it's running those encoded. So if it seems that I am, you know, not coming through on the other side very well, that's why. Probably need a better machine for doing this. Probably. Excuse me. Sorry about that. All right, cool. Let's see what we got. The next part is to actually, so next thing we do is create our clusters. And so it loads those artifacts in, and then it uses UMAP to start. See, this is the part I don't understand. This is the data science part. Hey. Yeah. I passed statistics, but that's about the best I could do. Let's go look this up a little bit. See if we can find more information on using UMAP. Hmm. Let's make sure I don't have anything else running here. See if I can't. I think I already shut down all my Docker containers. Yep, nothing else running. Sorry, guys. Be back soon, I guess. Oh boy, this is not something I enjoy. I don't like this. Yeah, I don't know. I can't. That's cool looking. That's about all I got. I know. I know. Let's take it out and see what we get. See if we can't understand HTTP scan. Maybe I doubt it. I doubt it. Determining the approximation of the data points, distinguishing the regions of high density from sparse regions, but what distinguishes HTTP scan from other methods is its capacity to dynamically adjust to different densities and forms of the clusters in the data, producing more reliable and adaptable clustering results. What is it? Clustering algorithm that is designed to uncover clusters in the dataset based on the density distribution of the data points. Sounds right. Seems like what we want to do. Unlike some other clustering methods, it doesn't require specifying the number of clusters in advance. Good. Making it more adaptable to different datasets, it uses high-density regions to identify clusters and fuse isolated or low-density points as noise. Okay. Seems legit. How does it work? I'm not going to understand it, but we'll try. Examines the density of the data points in the data set. Understood that. It starts by calculating a density-based clustering hierarchy, which creates clusters from densely connected data points. This hierarchical structure enables the recognition of clusters of various shapes and sizes. That's very broad paintbrush strokes here. The algorithm then extracts clusters from the hierarchy, taking into account the stability of the cluster assignments across different levels of the hierarchy. It identifies stable clusters as those with the consistent memberships at multiple levels, ensuring cluster information robustness. In addition, HTTP scan differentiates between noise and meaningful clusters by taking into account points with the low densities or the ones not belonging to any cluster. HTTP scan captures and eliminates the noise by constantly adjusting the minimum cluster size parameter and adding a minimum spanning tree. Oh, we need an ELI 5. HTTP scan has a number of parameters that can be adjusted to modify the clustering process to the specific data set. Here are some of the main parameters. Main cluster size. Parameter you set the minimum number of points required to form a cluster of points that do not meet this criterion are considered noise. Adjusting this parameter influences the granularity of the clusters found by the algorithm. Min samples, it sets the minimum in number of, I don't know what that is. I feel like that's a typo, but part of me feels like it's not. Let's figure out. minimum number of, I don't know. Minimum number of samples. Oh, okay. Oh, just look at the variable, Johnny. I think let's bump this up. I'm curious. Let's make it 10. Let's make it 10. Let's make it 10. And we can actually do this. We called it artifacts trial 1. And load our data. I wonder if changing boy, what did I do? What? Hold on. I know that's not right. It worked last week, no problem. So you know what? No, because we're doing false, and so this would run. Oh, cool, we're done. All right, cool. And we should be back. Sorry about that. Yeah, I didn't think it was going to take us out completely, and it took us out for a whole 30 minutes. So I do apologize. Um, but we're back. Okay. So right now, we can actually get back to it over here. So see what our clusters look like now. Now that we don't have NBSP and we don't have any of the /r/t crap or anything like that. So hopefully our data set's a little bit better. Just hoping. All right, let's see what we got. Still, how do we have NBSP and how do we only have, come on, how is there still NBSP in there? I call bull honky. And that made me. I mean, I reckon. Although 96 of our articles are in this first one. Violence, Justice Department, and rights. Fraud and healthcare. I kind of want to take this out, but I apparently cosine is not a metric for HCB scan. So let's go look at that. Yeah, cosine is not one. I wouldn't know which one to use. I guess it'd be the one that looks better, right? Let's that is not. Hmm. And we're back. Google is so behind. That made it way worse. Well, guys, I thank you for your time. I do apologize, but I am going to have to log here. Sorry that I took us offline for a good half hour there. So I do apologize for that. Hopefully next time we don't have to redo the encodings. I'm sorry, the embeddings. And we can continue learning and going through and getting some of this data going. Man, that really made it angry, didn't it? If I take no samples, do we get back to like where we were? I don't know. Come on. That's like the only thing I modified, I could have sworn. Hmm. Let's take one closer look here, and then we'll log off here. Oh, we're getting an error. Two typos. All right, we'll continue playing with this next time. As far as getting our clusters correct or closer, I don't know. I still have some NBSP stuff going on here. I don't know why. I thought I stripped all that out. I have to double check the way we were pulling those out. But, you know, I hope everyone has a wonderful Tuesday. Thanks for joining me today. I will see you guys on Thursday. Until then, blow out.